Hey viewers, in this video we will be discussing a JEE advanced problem 2022 that was asked from your trigonometric section. So let's get started with the problem. So let me write the expression sin alpha cos beta plus cos beta sin alpha by sin alpha plus cos alpha by sin beta plus sin beta by cos alpha. All right. So with the help of sine of alpha plus beta and cos of alpha minus beta, we are going to simplify this expression. So when we say cos of alpha minus beta, its formula is cos alpha cos beta plus sine alpha sine beta. So if I club these two together and these two together, the sine alpha and sine beta gets multiplied and this cos beta and this cos alpha gets multiplied. Thereby in the numerator we will be having cos of alpha minus beta. So let me club these two terms together. So in the denominator I will be having cos beta times sin beta. The numerator I will be having sin alpha into sin beta plus cos alpha into cos beta plus here I will be having cos alpha times sin alpha times cos alpha cos beta plus sin alpha sin beta. So in the numerator you are having cos of alpha minus beta formula, expansion of cos of alpha minus beta in both of the numerators. So I can remove cos of alpha minus beta commonly out. So I will be left with 1 by sin beta cos beta. What I can do is the sin beta cos beta can be written as sin 2 beta by 2, and even here I can write it as sin 2 alpha by 2. So the 2 goes to the numerator and then the 2 can be removed commonly out. So it is 2 times of cos of alpha minus beta times 1 by sin 2 alpha plus 1 by sin 2 beta. Just to write it in order, I am writing so. So 2 times of cos of alpha minus beta times the numerator I can write it as sin 2 beta plus sin 2 alpha. The denominator, the sin 2 alpha and the sin 2 beta gets multiplied, which equals 2 times of cos of alpha minus beta. The numerator I can use sin c plus sin d formula, which is 2 times of sin c plus d by 2 times cos c minus d divided by 2 divided by sin 2 alpha sin 2 beta. I can cancel the 2. So I will be left with 2 times 2 4 cos of alpha minus beta times sin of alpha minus alpha plus beta, and once again I am getting cos of alpha minus beta, so this could be written as cos square of alpha minus beta. In the denominator I am having sin 2 alpha times sin 2 beta, which is equal to 4 times of cos of alpha minus beta is 2 by 3. So you can write it as 2 by 3 square times sin of alpha plus beta is 1 by 3. So you can write it as 1 by 3 divided by sin 2 alpha into sin 2 beta. So 2 2s are 4, 4 times 4 is 16 by 9 into 1 by sin 2 alpha into sin 2 beta. Alright. A 3 gets multiplied over here. So the answer would be 16 by 27, 1 divided by sin 2 alpha sin 2 beta. So what I can do now is I can simply start to find sin 2 alpha. Sin 2 alpha can be written as sin of alpha. I can probably add a beta and then subtract a beta over here. Thereby I'll be left with an alpha plus beta and an alpha minus beta. Now this could be taken as your first term and this could be taken as your second term. So we can use sin a plus b formula, which is sin a cos B plus cos A sin B. Now the problem is to find the sine alpha minus beta and cos alpha plus beta. So let me write sine alpha plus beta, which is 1 by 3, and cos alpha minus beta is 2 by 3. These things are there in the question already. Now we are going to find cos square of alpha plus beta. Alright. So we know that sine of alpha plus beta is 1 by 3. So cos of alpha plus beta would be plus or minus root over 1 minus 1 by 9, because we are using the identity sin square theta plus cos square theta equals 1. So which should be plus or minus root over 8 by 9, which should be plus or minus 2 root 2 by 3. Now the question is whether it is positive 2 root 2 by 3 or negative 2 root 2 by 3. In order to understand this, we'll be using the definition. So in the question, that is why they are given you the range of alpha and beta. So beta is practically in fourth quadrant and alpha is in the first quadrant. So here we are adding alpha and beta. So let me write the range of alpha first. The alpha is lying in the first quadrant, 0 to pi by 4, and beta is in minus pi by 4 to 0. So your alpha plus beta will be in minus pi by 4 to plus pi by 4. This means that your alpha plus beta can either be in your first quadrant or your fourth quadrant. So if it is in your first quadrant, all the items are positive, and if it's in your fourth quadrant, cos is positive. And here we have come to find the cos of alpha minus beta, right? So the answer would be 2 root 2 by 3. And even more precisely what we can say is, see, cos is positive. Okay, so it has to be in the sine of alpha plus beta is positive. So alpha plus beta is essentially in the first quadrant because sine is positive. So naturally cos also has to be positive, but it doesn't matter. Alpha plus beta can be in between first and fourth quadrant. So cos of alpha plus beta is always positive no matter what. So it is 2 root 2 by 3. So the answer is 2 root 2 by 3 over here. And same thing I will have to do it for sine of alpha minus beta as well. So sine of alpha minus beta can be written as plus or minus root over 1 minus cos of alpha minus beta the square. So which is 4 by 9. So plus or minus 9 minus 4 is 5 by 9. So I will be getting root 5 by root 9, which is plus or minus root 5 by 3. Alright. So alpha minus beta. So alpha is lying between 0 to pi by 4. Since beta is lying between minus pi by 4 to 0, minus beta will be lying between 0 to plus pi by 4. And when I add these together, I'll be getting 0 to pi by 2. So alpha minus beta is completely in the first quadrant. Alright. So sine of alpha minus beta will be again a positive value. Alright. So I'll be having root 5 by 3 over here. So the answer would be 2 by 9 plus 2 root 10 by 9. I can remove my 2 by 9 commonly out. So I'll be having 1 plus root over 10, your value for sine 2 alpha. So using the same logic, you can find sine of 2 beta. So for sine 2 beta, you will have to write alpha plus beta minus of alpha minus beta. So the alpha gets cancelled now when the beta gets added up. So it is the same formula, alright. Here there we use sine of a plus b. Here you will be using sine of a minus b. So you'll be getting your same answer except a negative sign is introduced in between. So this is your value for sine 2 alpha and this is your value for sine 2 beta. So now I can substitute in this expression, my expression 1. So your first expression becomes 16 by 27 into reciprocal of sine 2 alpha. So reciprocal of sine 2 alpha would be something 9 by 2 into 1 plus root 10 into 9 by 2 into 1 minus root 10. So 9 times 3, 2 times 2, 4, 4 4s are 16, 4 by 3 into 9 into a plus b into a minus b would give me 1 minus 10. So which is minus 9, I'll be having minus 1 over here. So the answer will be minus 4 by 3. Just found out minus 4 by 3 to be your answer, but it is not the final answer because let's say that this expression to be a. Now we'll be have to finding a square and then we'll be have to using your greatest integer function. Alright. So let me first write this as a. So a square is 16 by 9 and it will be 16 by 9 will be around 1.7 something, it doesn't matter. So when I find the greatest integer function for it, your answer would be 1. So I hope you learned something new from this video. Please subscribe us for more such content. Thank you.